Science is skepticism. Science is questioning things. Science is suggesting solutions and testing them. Science is not about dogma.
Bienvenue à tous dans cette série de vidéos préparée par l'association des Climato-réalistes où l'on va donner la parole à Richard Lindzen. Richard Lindzen est l'un des plus grands climatologues au monde qui a fait toute sa carrière au prestigieux MIT, le Massachusetts Institute of Technology. Il a aussi travaillé pour le GIEC, le fameux groupe d'experts intergouvernemental sur l'évolution du climat, et il est enfin membre du comité scientifique de notre association. Et Richard Lindzen ne croit pas que le climat soit déréglé ou que nous vivrions une crise climatique. Nous faisons donc fausse route quand nous nous imaginons que nous devons nous alarmer de l'évolution des températures. L'effet de serre, la fonte de la banquise, les cyclones, mais aussi le fonctionnement du GIEC, la fabrique du consensus ou encore l'idéologie qui règne dans la science aujourd'hui, c'est de tout cela dont Richard Lindzen va nous entretenir. Richard Lindzen, bonjour.
Bonjour.
Hello. Thank you for coming.
My pleasure.
We're going to speak in English and
Good.
there will be subtitles in French for our French
Sure.
viewers. And first of all, I would like you to present yourself. Tell us who you are and what you did on what is your work in the field of climatology.
Well, first of all, until 1990, I would never have called myself a climatologist. No one in my department ever called themselves a climatologist. I was a meteorologist, a dynamic meteorologist. There were oceanographers, there were marine geochemists, there were geologists. All of us were interested in climate as a component of what we were doing. It was an interesting question. The people who were, quote, climatologists, that term was reserved for the record keepers for the government. They kept records. It was a serious job, but not very theoretical. There were other people who were very interested in climate. Well, many of us were. Most notably, for instance, in Leningrad at that time, today St. Petersburg, there was the Hydrodynamic Institute or something like that. And it had a lot of people working on climate. There was a man called Yuri Israel, there's Budiko was there. But, it was something, a topic within the general fields. Today, in my department at MIT, everyone's a climate scientist, even if they don't work on climate.
So what did actually change at the time?
Money.
The difference between, first of all...
Look at France. When I was a student, there was one person in Paris who worked in the atmosphere, a man called qu'il. Today there are hundreds, and most of them know very little. And the reason is, once this became an important political issue, then funding came, and you had a new group of people. This used to be a very small field.
And how do you define it?
How do I define it? There's no definition. There were too few people who actually were interested in studying the system. So you then developed areas like impacts. So for instance, in Germany, you have the Potsdam Institute for Climate Impacts. What does this mean? This means that, you may know nothing about climate. Maybe you're working on mice or cockroaches or God knows what. If your proposal says the impact of climate on these, now you're a climate scientist. So most climate scientists are impact studies, because that includes anyone who's studying anything.
How do you scientifically distinguish climate from meteorology? Climatology
Well,
and meteorology.
the climate system, of course, involves the atmosphere, the oceans, to some extent the solid Earth, the orbital mechanics, solar physics. It involves so many things that there's no one who's really an expert in all of it, including myself. When you get to the paleoclimate, you know, the analysis of ice cores, the arguments about isotopes of oxygen, do they represent ice or temperature and so on. You are dealing with a lot of topics, and frankly, I know of no one who's an expert in all of them. You also, when you get into CO2 and you start demonizing it, you better also know about photosynthesis and the chemistry of that. So, you know, it was always understood this was one of the best examples I know of interdisciplinary, multidisciplinary studies. And people understood at one time that you made your contribution, you worked with other people, and so on. The notion that I would be an expert in glaciation would be wrong. I mean, I know of only 2 or 3 real experts in glaciation. I might ask them for help if I were working on it. But to assume that a person who says I'm a climate scientist knows all these things, that would be sheer nonsense.
You mean that climatology is too big?
Yeah, sure. It's a kind of synthesis of so many things. You can have your ideas on it, you can look at specific things. At one time, you know, I think the Russians had it pretty much right during the Soviet period, in that they looked at the data, proxy data mostly for climate, and they realized that there were 2 crucial questions. One, they observed that in most major climate changes, the tropics were relatively constant, within a couple of degrees. Mm-hmm. What changed was the difference in temperature between the equator and the pole. And this was a matter of dynamics. So you had these questions, and they were some. In terms of phenomenology, you had the major glaciations, you had the Eocene, you had other things going on. So there were questions. How did they work? There were questions. Why did ice begin a few million years ago? What was its impact? And a lot of great questions. And people worked on it from their disciplinary views and so on, contributing what they could. Milankovitch, for instance, who I think gave the best insight into the ice ages, was an astrophysicist.
So maybe you could explain what Milankovitch did,
okay.
What he said.
What he did was relatively simple. We had begun to realize that there were cycles of glaciation. That roughly speaking, there was a dominant period of about 100,000 years, but there were other things going on. He realized that with these large ice sheets, as with any glacier, what was important? What is important with glaciers is summer. Essentially, if summer is hot, then the snow that accumulated in the winter, which always accumulates in winter, winter's always cold, won't last. If the summers are cold, the ice lasts, and so there is a new base that it builds on, and it builds on, and it builds on. It has thousands of years. It can build to 2 kilometers, 3 kilometers, enough to be noticeable. And then, you know, it breaks in certain ways and so on. At any rate, Milankovitch realized that the crucial thing would be that, and he also realized that due to the orbits of the Earth, the obliquity, the precession of the equinoxes, the eccentricity, that the Arctic temperature, Arctic insolation, excuse me, not temperature, changes a lot. So, you know, for example, when we talk about doubling CO2, we talk about 3 watts per meter squared. But if you look at the insolation at, let's say, 65 degrees north, it's, you know, varies 100 watts per meter squared over these orbital variations. So he suggested this probably was driving the glacial cycles. Now, you know, when you have people in different disciplines looking at things, different backgrounds, you'll make mistakes. And so there was a big program in the US called Climat, about 30, 40 years ago, to examine the last glacial maximum, which was about 18,000 years ago. And they were looking at the Milankovitch parameter, the insolation at 65 degrees in June. And they said it had similar peaks to the glaciation, but it didn't seem to work well. They were comparing insolation with ice volume.
Assuming that it was the same equivalent.
That one caused the other, that's what they did. You know, it took 2 young scientists, a couple of Swedes, Edvardsson and some colleagues, and then another guy, Gerard Rowe, to realize that there was a stupid error in this. If you're looking at the insolation, the incoming sunlight, you want to compare it with the rate of change of ice volume, not the ice volume. And that worked beautifully.
So the derivative of the volume.
Yeah. And that correlates excellently. Better than almost anything I've seen in geophysics.
When did it take place, this discovery?
This work?
Yes.
Probably 2009.
It was very recent.
2003. They didn't know of each other. I mean, these were just people reflecting on it.
So do you think that this is a major contribution in the field?
I think for the ice ages, sure. Now, you had, you know, the CO2. They were saying, well, they were looking at globally average CO2, not the one that was relevant. So that varies a watt. So they're saying, yeah, we agree, this can't cause it. It must be due to the orbits, but the CO2 must amplify it, otherwise it couldn't occur.
Yes, well,
it's crazy.
We'll speak about this, of course.
That's just bizarre. No, but you know, in a normal world, these guys, you know, Edvardsson et al., would get prizes for this. This is not a normal world.
So they didn't get anything?
No, no recognition, whatever. In fact, Rowe, to publish it, had to include a little sentence in it saying this has no implications for CO2 at all.
How did it start, this story of CO2? What was the first time you heard about it?
Well, first time I heard about it is a different
question, sure.
No, the issue began with the beginning of the environmental movement. I mean, the origins of this issue are political from the beginning. The question was, you know, what aspects of nature gave you the most political leverage? So, you know, climate, people don't understand it. You can say what you want about it. It was early on recognized climate was a good way to get a handle on the energy system. And that was already 60s.
But at the time, we also talked about cooling of the Earth.
Yeah, sure. The question is, how can you use climate? Okay, the temperature's been going down since 1940. It's going to cause an ice age. And what's the reason? Well, you know, energy creates sulfates, and that's reflecting light, and that's going to cause it all. Okay, that went for a while. It was actually got a lot of traction. You had all sorts. The New York Times covered it extensively, the coming ice age.
Well, was it really, was there at the time a kind of consensus about the coming ice age? Or?
Not quite, not quite. Mm-hmm. I think most people thought it's not too serious. But the environmental movement took it seriously until the temperature stopped going down in the 70s. And so the question is, how do you hang on to climate as an issue? Well, the temperature's going up. CO2. CO2 is perfect for this, because no matter how clean you make the burning, at the end you have CO2. That's the product of perfectly clean burning. Mm-hmm. No CO, no sulfates, no nothing. So you had to make that a demon. It's a very strange demon, isn't it? It's the only demonized, the only pollutant I know. If you cut it by a little bit more than a half, we're all dead. I mean, what pollutant is so essential for life? I mean, your mouth has tens of thousands of parts per million. The space station allows 5,000. I mean, it's really, I mean, it's amazing how much illiteracy this assumes. It has to assume people do not know there's photosynthesis. They do not know CO2 is essential for plants. They do not know that if you're growing tomatoes indoors or any other vegetable, you pump CO2 in to make them grow faster and better. Instead, you can make people think it's a good idea to get rid of it.
Yes.
And if you ask them, do you know you'll die if you get rid of it? Huh?
And scientists, you and in your department, or how did they react when this idea of bad CO2 came out and began to grow in the public debate?
First of all, I mean, forget the department for a moment. You know, I mentioned it was a small field. You know, at least in the US and in France and in most of the world, all of a sudden in the 90s, the momentum, the IPCC and the Bellagio conference and other conferences, funding in the US went up by a factor of 15. I think in France it must have been very similar. You created a whole new community. You now do have hundreds of climate scientists at the University of Paris. They all know the only reason you have hundreds is because of the CO2 climate issue. They know that their job disappears if that issue disappears. So of course they support it.
So you mean that it was other people who came in science?
Partly. Yes, you expanded the field greatly. All of a sudden you had 100 people here instead of 1. All of a sudden in the US you had hundreds of departments instead of 12. So sure, a whole new group of people. But also for anyone who is still active, not retired, your administration wanted it. There was the money available and so on. So, for instance, in my department, you have people who work on extraterrestrial planets, people who work on all sorts of things unrelated to climate. They all became climate scientists. That was the designation.
And how about the relationships between these new scientists and the one who were there?
It's like a lot of things. It became part. I mean, already in 1990, I had made my opinions and views known, and The New York Times actually covered it. And I went to a reunion of my high school, which was something called the Bronx High School of Science. So it was a very successful high school and very good. And they asked me, they said, don't you realize that your position is politically incorrect? Already it was part of the canon of political correctness. Newsweek magazine in 1988, when you had a Senate hearing and so on, said all scientists agree.
Already in 88?
Already in 88. What is the purpose of that? The purpose of that, and I have said this on other occasions, almost no one in society today, especially among the educated, actually knows anything about science. If you ask somebody in literature, they're proud of the fact that they cannot add numbers.
Yes, we have the same here in France. It's
yeah, everywhere.
Everywhere.
And so the question is, how do you get them on board, involved? Turns out it's very easy. And it took me a long time to realize this. These people who do not understand anything about science or math or anything know they don't understand it. They're insecure. They want to know that they're safe. So you tell all scientists agree, now I can say this and I believe in science. That's why you give them a simple picture. Greenhouse effect, that's just putting a blanket on. Now I understand science. The trouble with it, and you can tell immediately that these people do not understand science, they use a word which is the opposite of science in English. It's a very peculiar word, science, because its opposite is the very same word with the definite article in front. So the opposite of science is the science.
You mean the science is a kind
contradiction in terms. It says there is a science, it is dogmatic, there's no questioning it, I believe in the science. It's a religion. Science is skepticism. Science is questioning things. Science is suggesting solutions and testing them. Science is not about dogma.
How such a new dogma could be so successful?
Oh, it's happened before. It's happened before.
So what are examples of this? Well,
eugenics,
in general,
eugenics
on Lysenko, on this kind of things.
Well, Lysenko is different. Lysenko is different. Lysenko had no particular support,
so maybe
except that Stalin would kill you if you objected. So that was a powerful argument. But eugenics was more subtle. Eugenics began in 1880 with the creators of modern statistics, Fisher, Galton, so on, great figures. And nobody cared at all, because the statisticians had a sophisticated mathematical approach to evolution. And the people we were talking about, the humanists, the socialists, couldn't understand what they were talking about. This all changed in 1900, when we rediscovered the work of the monk Mendel with peas, that there was a genetic component. All of a sudden, the picture arose that feeble-mindedness, stupidity, and so on, were a single recessive gene. And if you could get rid of this gene, you could get rid of such people. That was simple enough, and then it caught on. Now people, quote, understood the science. And it continued and had terrible ramifications through the 1930s. But some of the most important people in the world were very enthusiastic, George Bernard Shaw and so on. Eugenics was part of the progressive political movement. It led to a great many disasters, including racial politics of the Nazis. And so that disgraced the field, and even human genetics was dead for almost 10 years because of it. But no, as soon as you simplify something so that somebody outside of science says, I understand science, you've got them.
Could it be that, well, it's not eugenics, and in general, when you provide this argument, people say, but, well, you're comparing environmentalists with the Nazis.
No. You asked something else. You asked, was there an example of a complicated theory that got accepted by non-scientists? And eugenics was a good example. And the reason it's a good example is it showed that if you gave a sophisticated argument, it didn't go. You had to make it a simple argument that allowed these people to believe they understood science. The same thing with the greenhouse effect. It caught on because you told people a greenhouse gas is like a blanket, and a blanket keeps you warm. They said, now I understand science. Yes. If you said that it involved radiative transfer and convection and so on, and emission level, no, it would not catch on.
How do you think it was possible to create the consensus, well, apparently consensus around the question?
You assumed it from the beginning. As I mentioned, in 1988, when you had the Senate hearing, there was immediately a cover of Newsweek magazine showing the Earth on fire and the headline, all scientists agree. Consensus, whenever you polled the American Meteorological Society, there was no consensus. When you claim 97% and you look for the articles, you don't find it. But what is the use of saying it? Well, it's for the people who are not scientists to hear that all scientists agree. Okay, I'll agree.
And do you get support from, let's say, mainstream scientists who don't want to speak out, but say, well, okay, in fact, I agree with you, but I cannot say it?
I would say, first of all, the vast majority of scientists know nothing at all about climate, and more important, they don't want to know anything at all about climate. It's too dangerous a subject. I know Nobel laureates in physics, field medalists in math, and all of them, when it comes to climate, will say, oh yeah, it's a big problem. We endorse anything. Why get involved? Moreover, as I say, scientists are people. Scientists have their own political preference. And like most academics, they're on the left, and the left wants climate change to be an issue. And so they'll go along. The only Nobel laureate I know that doesn't go along is Ivar. Yeah.
Yes.
Ivar doesn't, but he's very old and he's not well.
There are also probably other phenomena you wrote about other aspects of the story. Is during the Cold War, the fact that well, science were not designed anymore to increase knowledge, but to solve problems. And there is something like that probably here is, well, to get money, to get funding, you have to create, you have to say that there is a problem somewhere.
Yeah, I think in this case you didn't have to.
Sure, but you have to
No,
to convince
what
people
happened
that...
here, no. You have a problem, and Dwight Eisenhower, President of the US and Allied commander during the war, pointed it out already in the 50s, that there was a danger with science being dependent on the government. And the danger, you know, it's great if the government supports science, as long as the government has no interest in the outcome, one way or the other, just wants to know, and it's fine. But should the government ever have a position on the science, it's a very bad system. And that's the case here. The government already decided it wanted climate. The environmental movement, political movements wanted it.
And it goes back to the 60s? Or
already in the 60s, it was understood climate was a useful handle on it. But, you know, all through, I remember the 80s and late 70s, there were meetings being held by international groups, you know, about basically how can we push climate as an issue. I saw somebody say it began in '88. That's silly. Of course it didn't. I mean, I remember, you know, the EPA in the US was already encouraging people to find out how to use climate as an issue in the 70s. And in fact, the EPA supported Jim Hansen. Already you had the environmental movement, things like Environmental Defense Fund, Natural Resources Defense Council. All these very well-funded environmental groups were serving the EPA as reviewers of their programs and pushing this. So you had all this build-up. And even for Jim Hansen, who is now supported by the EPA for this, you waited until summer and you tried to shut off the air conditioning in Congress and so on, so that there would be the impression of heat. When Newsweek had the cover, it was the earth in flames. Mm-hmm. I mean, you know, again, there's something absurd about this issue. You're talking, you know, look at the UN and so on. What are they saying is the tipping point? 1.5 degrees centigrade. And we've got 1.1 already. So they're saying in another 0.4 centigrade, the world comes to an end. Huh?
And that's
that temperature difference is between the time you get up and the time you have lunch is much bigger than that. That's going to do it? Who could be so crazy? Well, I'll tell you who would be so crazy.
Yes, that's the next question, of course. How can it be that so many clever people are involved in this?
People do not look at numbers. You tell them the next 1/10 of a degree, 1/10 of a degree, fine. I don't think people think quantitatively. When you look at the financial pages of a newspaper, you know, if the market went up 100 points or 10 points, the graph looks the same. It just goes up. I think this prepares people to ask just, did it go up or did it go down? And so you show them it went up 1/2 degree. They say, wow, look, it went up. But I don't know what you do about that.
We can also separate different kind of people. Of course, there are well, general population, which is not
no, the general population is sensible. General population understands.
Yes, that's the point.
It's the educated who don't understand.
So they've
been educated not to understand.
So maybe we could talk about believers or non-believers. To be short, believers, I mean those who believe that climate is disturbed, we live in a climate crisis, and people who do not believe.
Oh, no, I think, at least in America, and I suspect here, ordinary people are very skeptical about this. There is something called common sense. The people who believe this are several categories. If you're talking about young people, they've been propagandized in school for now almost 2 generations. So they've been taught this before they even know how to add single-digit numbers. Okay, for them, depends. You know, I'm not pessimistic. I don't think even children are automatons. So the children know they have to say this, but their parents maybe tell them no. Except, you know, as you go to 2 generations, their parents went through this, so it's a little bit problematic. But I think ordinary people understand. I mean, even here with the yellow vests, they understood that the price of gasoline was more important than climate change.
Sure.
So you have that. But I think for educated people, there is a problem with education. And it is that, you know, kids at the university realize the important thing is they have to please their professor. The professor may be crazy, but it doesn't matter. So what is the skill they learn? The skill is how to rationalize anything. If the professor said this, how can I justify it? Ordinary people have a more concrete sense of the world. They don't have to rationalize things. But educated people often learn to rationalize. And many of the professions are like this. I mean, you know, you're a lawyer. You have to argue each side of the case. I mean, there's something in that that makes people vulnerable to very bizarre narratives. And the issue of climate as a catastrophic existential threat is clearly fantasy. I mean, from beginning to end, it's absurd, and yet you have politicians acting, you know, I don't know what motivates them, but I suspect for many of them, they say, my gosh, an opportunity to go down in history as the person who saved the earth. I mean, it must have some appeal.
What do you say? A little bit pessimistic for teachers. I'm a teacher.
Yeah.
You also are a teacher. And is it what you say is in some way that whenever we teach, we don't do a good job because
well, it depends on what you're teaching. If you're teaching engineering, if you're teaching mathematics, if you're teaching physics, if you're teaching fluid mechanics, you are teaching something that is intrinsically objective. If you're teaching history, if you're teaching social science, sociology, political science, you're venturing into opinion. And teaching, separating teaching from indoctrination gets a little bit tricky. We all know there are excellent teachers, but they have to make clear that they are giving their views, explaining why they think that way, and leave an opening for questions.
This was indeed, well, Max Weber wrote about this a century ago already.
Of course.
But he had in mind teaching human sciences, history, geography, etc. Indeed. But now what we see is that it's coming to science, to real science.
Oh yeah.
And
well, look, America is now in a very strange position. You know, I'm in the Department of Earth, Atmospheric and Planetary Sciences. Our students have to sit in a set of lectures on racism in the earth sciences.
So there is racism in earth science.
Oh yeah.
It's new.
I have, you know, friends in mathematics. They're going crazy, you know. All of a sudden, mathematics is racist, precision is racism, being on time is racist. I have never seen so much racism in America as these propositions. I mean, you know, my family is mixed racial. For blacks to be told they can't keep time, they can't be on time, they can't do arithmetic and so on, whoever heard of that? And yet we're having that as forced down people's throats in the US as allegedly on behalf of black people.
So it's quite strange seen from France to imagine that in America, which is the center of the world as regards science, and
oh yeah,
how can what's going on there?
France had a revolution, you know, in 1780 something.
Yes, 1889.
In which you change the calendar, change this, change that. Yes. That happens every so often. I think America's going through one of those stages. The question is, will it come out of it?
But, well, back to the climate.
Yeah.
Do you think that science is corrupted definitely, or is there any chance, any hope that things will go better?
Well, you know, there's always hope. One of the things that's very strange about climate, you know, for instance, in the US, when there is an issue that involves national security, about weapon systems, about detection of submarines, things like that, our procedure has always been to have red and blue teams. We organize scientists into the two views and have them oppose each other and see what the weakness is in each situation. With climate, there has been an absolute refusal to have any discussion. This goes back quite a way. So, for example, Will Happer, who you may know, his colleague, professor of physics at Princeton. He was for a while in charge of science in the Department of Energy. The Department of Energy in the US supports almost all of theoretical physics, high energy physics, but also a lot of climate science. And he made the observation, when you asked people in high energy theory to come in and explain their work, they were happy to. They were happy to discuss what they were doing and so on. When you called the people in climate in, they said, "You have no right to ask me." I mean, it was just a different attitude. It was just, you knew they were guilty, so to speak. And so there's never been a discussion. There's a gentleman right now who's written a book, you may have seen it,
yes,
Steve Koonin, called Unsettled. But you know, for years he accepted the climate story. And he, however, attempted to have a meeting where he had 3 people who were questioning climate narrative and 3 people for supporting it. And what became perfectly obvious to anyone in such a meeting is there were questions. It was not settled. Mm-hmm. Now, his book is interesting. I don't know if you've seen it. I would normally disagree with it. What does he do? He just goes to the IPCC and the national reports and says, look, they don't say what you're hearing. Yes, the UN says they found no relation to extreme weather. So where did it come from? It was made up. And he's just saying, read the documents and you will see what you're hearing is not strictly true. Now, there are plenty of things I wouldn't agree with the IPCC, but I mean, even it doesn't go as far as the propaganda you hear. and in particular the issue of an existential threat. I have never seen that in an IPCC document. And indeed, one of the strange things about these documents, you remember some years ago, I think it was the third report, said we now believe with a 90% certainty that most of the warming since 1950 is due to man's activities, including aerosols, so you could always compensate. But it didn't matter. The statement was innocent. Not much warming had occurred, about 2/3 of a degree. It didn't imply anything terrible. So it was an innocent statement. It may even be wrong. The temperature may not have even been a good index for climate. Doesn't matter. All of a sudden what happens? The press gets it, the politicians get it, and say, see, now we know the world is coming to an end. And surprisingly, what do? They increase the funding for the scientist. And so the scientist shuts up and doesn't tell them, I didn't say what you said.
So there was an article in a recent article in Judith Curry's blog about research cartels. And it's an interesting idea in an article in epistemology written some years ago about the fact that scientists are doing a kind of private way of...
peer review is a disaster. I mean, do you realize that before World War II, peer review was unusual? Virtually no scientific journal had peer review.
But it became important to have peer reviewing.
Why did we have peer review?
To check that it's that science is sensible.
Nonsense. Paper shortage.
So you don't think papers should be reviewed before being published?
Look, let me give you an example. The Quarterly Journal of the Royal Meteorological Society, it's a good journal. Until the 60s or until the 70s, when they asked someone to review a paper, they gave instructions. And the instructions were, you cannot reject a paper .
So now, Dick, I would like us to discuss about climate itself and science itself. And to start with, maybe we could evaluate, if you could tell me, points of agreement. What can be said about climate at our decennial scale, facts with which everybody could agree, if any?
Yeah, I mean, there are a lot of things one could agree on, although the interpretation of the agreement might vary. So, you know, nobody is arguing that CO2 is not increasing. It's increasing. I think there's a very substantial agreement, not total, that the increase in CO2 is due to industrial activity or cement mixing or God knows what. There is no disagreement that CO2 absorbs in the infrared. There's no disagreement that a priori adding CO2 should cause some warming.
And the sum is important because
yes, of
quantitatively
course.
There are a lot of disagreements.
It could be negligible. Mm-hmm. And indeed, if the usual metric is doubling CO2, and the usual agreement is if you double CO2 and kept everything else constant, you might get 1 degree of warming. Until recently, 1 degree of warming was considered negligible. And then all of a sudden politics enters. Arbitrarily, it's decided that another ½ degree is the end of the world. This is stupid, but you know, that's what you have. You suddenly have this funny feedback. So the politicians decide that another ½ degree is terrible, and then you have scientists saying, well, if you don't do this, you might go over a ½ degree, although they don't suggest it's the end of the world, but if the politicians want to treat it that way, okay.
Okay, and also a point of agreement is the fact that the Earth has warmed during the last
that you
century.
say, and it's probably true, because if nothing else, we were in what was called the Little Ice Age, and there's no question something happened around 1800. From about 1500 to 1800, alpine glaciers were advancing. And then, beginning around 1800, a little after, alpine glaciers in the Alps and elsewhere began retreating. So something happened. On the other hand, there's agreement that whatever happened before 1950 was not due to CO2 because the increase was too small to do anything. So, strangely enough, I think there has to be widespread agreement that climate changes without us.
So now, this is for agreement. Now, disagreement starts at the middle of the 20th century.
Disagreement is actually more extensive than people think. Mm-hmm. So, for example, I think certainly I disagree with the notion that climate is defined by one number. I mean, I'm interested in the temperature difference between the equator and pole, why the tropic. The question, actually, there's disagreement about the question. But then, even within the narrative of greenhouse warming, of course, there are arguments about sensitivity.
So maybe you can define, distinguish.
Sensitivity is saying, you know, we said if you just have CO2 doubling, you get a degree. Many of the models suggest you might get 2 degrees, 3 degrees, 5 degrees. And that is because in the models, there are what are called feedbacks, that when you warm a little, something else changes that causes you to warm more. None of these are rigorous. You know, they assume water vapor will increase, and on the other hand, measurements from space suggest that this is not working. So there are plenty of arguments about it. One of the more subtle arguments, in a way, is Le Chatelier's principle. That, you know, long-lasting natural systems should be dominated by negative feedbacks that prevent them from going awry. And yet the climate narrative is built on the assumption that nature is evil, it's out to punish us, and whatever we do, it'll make worse. This is a very peculiar Manichaean view of the world.
So you talk about Le Chatelier's principle, but of course mainstream climatologists know about this, so they have an answer. In general, they say that well, feedback is the negative feedback is less powerful, and that's why we consider them as positive feedback.
The whole issue depends on assuming there are positive feedbacks.
The
trouble is none of them have ever been shown.
So do you have an idea of what is the sensitivity, the climate sensitivity? I mean, if we double CO2...
I'm pretty sure doubling CO2 will give you a ½ degree.
Half a degree?
Yeah.
Okay.
I've said this for 30 years. There are a lot of reasons for it.
So could you explain?
Yeah, sure. First of all, if you make a simple energy balance model and you take the increase in CO2 and increase in all the other greenhouse gases, and you ask what sensitivity would you need in order to match the observations, you always get a very low sensitivity. The answer of the people who wish to say it's bad is, well, of course, there were aerosols, sulfate aerosols, that canceled the warming, so you don't see it all. But by now, the aerosol people have shown that, you know, there's a limit to how much you can do with that. Mm-hmm. And so, with the current limits on aerosol, it would be hard to match the observations with more than 1 degree. And it's easy enough with a ½ degree. In addition, there are all sorts of subtle things. So for instance, if you have a very sensitive climate, the warming or change in temperature takes a long time. And so for instance, if you have a volcanic eruption, and if you have a low sensitivity, then what happens, you have 2 years or so when the temperature is cool, and then it's restored to normal almost immediately.
And this is what we observe.
If you have a very sensitive climate, then you have the same first 2 years, but then the relaxation is very slow. You don't see much evidence of that. So, you know, if I look for evidence that there's a high sensitivity outside of models which enforce it, I don't see it.
So you talk about models. Maybe we could elaborate on this. What actually the models?
Well, the models are, you know, initially they're reasonable attempts to replicate a physically coherent system. There are problems. You are essentially modeling fluid mechanics. You're modeling fluid mechanics where you have the oceans and the atmosphere. Each of them is what is called multi-phase. You have water vapor in all its phases, you have salt, you have this. So it's a complicated system. To make matters even worse, no one has ever proven that you can numerically model a fluid and converge to the right answer. So there's a kind of hope that you can do this, but then you have the additional problem for the atmosphere and the ocean that you're dealing with at the largest and planetary scales, and at the small end you're dealing with millimeters. And even today with the most powerful computers, dealing with such a range of scales, which immediately means you need to have very fine time resolution and so on, it's still far from possible. And so what do? Well, you take the sections that you cannot resolve and you approximate them with what's called parameterizations. That's how you deal with clouds. But we don't know enough about clouds to parameterize, so you have a lot of freedom to fool around. And you had one example which I thought was quite lovely. There's a man at the Max Planck Institute named Moritzen. He's actually, I think, Danish. And he was working there with a man called Bjorn Stevens, who is the main modeler at Max Planck in Germany. And Moritzen was explaining how they work. He says, we start out by choosing the sensitivity, and then we fool around with the clouds and so on to make it work consistently with what we observe. But you know, when you come to what's observed, what are they looking at? They look at this, quote, temperature record, which is really a record of the so-called temperature anomaly. And if you take the same model and say, is it putting the seasonal averaged highs and lows in the right place? No. It's not getting regional climate, it's not getting that. So I think the modelers like to have one number, because it's easy to match one number if you adjust the clouds and adjust this. If you actually looked at the numbers regionally, you'd see the models are not working.
And do you think it could become useful at some time, or?
You know, it's a good question, and I don't know the answer to it.
Are we really far away from?
I don't think they'll ever be good for long-term forecasts. I think there are intrinsic problems. For short-term forecasts, I would say today weather forecasts for 2 days are pretty good. But we all know, you know, when you look at your phone and look at the forecast, it's wrong about 30% of the time for 2 days. And the skill diminishes. And by the time you're at 7 days, everyone agrees it's pretty close to zero. Mm-hmm. I remember for years you'd be on panels to assess the Weather Bureau's progress and so on. And I remember every year you'd get the same thing. It is, we've now advanced forecast skill to 6 days, 7 days. And then you come back 10 years later, and what have we done? We've advanced forecast skill to 6, 7 days. It seems like there's a kind of barrier there. Mm-hmm.